Hello everyone, we are going to look at an example where we apply second derivative to determine the nature of the turning points. And this is our question. You are given fx equals to 4x squared plus 1 over x. Find the first derivative and the second derivative of fx. Then find the position and nature of any stationary points. So we're going to start with finding the first derivative, from which you shall get the second derivative. Our function is fx equals to 4x squared plus 1 over x, which we can write as x power negative 1 for simplicity when we are differentiating. So the first derivative, which we write like that, is bring the 2 in front, which will multiply the 4 to get 8, and then x power 2 minus 1, which is 1, and then bring the 1 in front, minus 1, x power negative 2. If you have troubles in differentiating, you can watch my previous videos on differentiation. So our answer will be 8x minus 1 over x squared. That is the first derivative. Now the second derivative, so let me first underline this. This one is our first derivative. Now our second derivative. To find the second derivative, you differentiate the first derivative. So we are going to differentiate this answer to get the second derivative. But instead of using this, we shall use this. So differentiating 8x, it gives us 8. And when we bring this in front, it will be plus 2x power negative 3, which is equal to 8 plus 2 over x power 3. So that is it for the second derivative. And remember, our question tells us to find the first derivative and the second derivative, then find the position and nature of any stationary points. So the next part we shall be doing finding the stationary points. So stationary points, we use the first derivative. At stationary points, the first derivative is equal to 0. So our f is equal to 0, and our f was 8x minus 1 over x squared, which is equal to 0. So we are going to solve this equation, and solving it, you have to first multiply through by x squared, which will give us 8x cubed minus 1 equals to 0. And when we take the 1 at the other side, it will be 8x cubed equals to 1. And so x cubed is equal to 1 over 8. And we get the cube root of this, which will give us x as 1 over 2. So this is the value of x for the stationary point. And then you can get the value of y for that stationary point. by substituting the value of x into the original fx, which is 4x squared plus 1 over x. So our y equals to 4x squared minus, is it minus plus? Is plus 1 over x plus 1 over x. So substituting in to find the y value, it will be y equals to 4 times 1 over 2 squared, and then plus 1 over x, which is a half. And I think we shall get, this one is 1 over 4, and it cancels, that is 1 plus 2, which is 3. So our y value is 3. So our stationary point is a half 3. But we have to determine the nature of the stationary points. And remember, this is our aim in this video. We said you use the second derivative, this one here. You use the second derivative to find the nature of the stationary points. Note, if our second derivative is greater than 0, and the point is minimum. And if the second derivative is less than 0, our turning point will be maximum. So let's use these two facts to determine the nature of our turning point. So our second derivative was fx equals to 8 plus 2 over x cubed. So substituting in the value of x, that will be 8 plus 2 over 1 over 2 cubed. And 1 over 2 cubed is 1 over 8. We shall go up and we get 2 times 8, which is 16, plus that. So our second derivative is positive 20 what? 4. And since we've said if we get a value which is greater than 0, a positive number, it is greater than 0. So the turning point is minimum. In this case, our x which was a half and the y which was 3 is minimum. Thank you.